Hello, my name's Melia, Head of Marketing for Citrine Informatics. And today I'm going to be talking about optimizing the use of surfactants in shampoos through a process using machine learning. We all know that our consumers are very cognizant of the ingredients that are being used in our personal care products, and we need to look at the use of plant-based ingredients and remove some of the ingredients that we've used in the past. And what I'm going to show you today is not just hypothetical. This is a case study from one of our customers, a large consumer goods company who makes skincare products. Originally, their suite of skincare products used petrochemical-based, plant-based alternatives. They were losing market share to new entrant competition, and typically the job of reformulating a suite of products would take around 5 years to commercialize. What they did using the Citrine platform was to reformulate 3 different products, hitting specific rheological specifications in just 2.5 months. This is a reduction of time to market of 80%. So what I'd like to do today is to look at how AI can be used to do something like that. Let's imagine that we have a shampoo product. It's currently very popular, but we want to investigate the surfactants being used and try out some new plant-based surfactants. We need it to maintain its viscosity, maintain its rheology type, and of course the formulation must be stable. And as we know, stability tests can take a lot of time. So let's think about how machine learning works. It's a simple, iterative, AI-driven experimentation workflow. First, you have data. It can be 20 to 30 data points in an Excel spreadsheet that you drag and drop into the platform. If you've got more data in databases and you want to use the API, that's fine. Then, with one click of a button, you can create a default model. This default model is based on our experience over the last 12 years, what works and what doesn't. And you can put your domain expertise on top of this model and improve it. You then get to tell the AI where to look. You put boundaries on it, how many ingredients it's allowed to propose, what ingredient fractions it's allowed to use for different types of ingredients. And then you set target properties. So we can set a rheology type, in this case Newtonian, a certain viscosity that we need, and also, of course, a target on stability. What the platform then does is it looks at many millions of different options, predicts the properties of those options, and then generates a ranked list of 500 potential experiments to take to the lab. Those predictions come along with error bars. So you have an estimate of the uncertainty of the predictions alongside the predictions. And that's crucial because it enables you to figure out which of these options is a safe bet and which is more an exploratory experiment. And you can use your judgment and strategy to decide which experiments to then take to the lab. And it's this extra information that reduces the number of experiments you need to hit targets. So you take a batch of experiments to the lab, run your tests, feed those test results back into the platform, retrain the model, and that makes it even more accurate, which means that the next batch of experiments it suggests are even more likely to be on target. This is not a case of making a model to automatically come up with the best possible formulation straight away, especially when you're dealing with this kind of small data sets that we deal with in the personal care market. What it is a way to drive experimentation always in the correct direction, getting closer and closer to your target values. So I've opened up the Citrine platform and you can immediately see the workflow that I outlined before. We have the training data, AI models, search space, and candidates. But let's start by looking at the data. And to do that, I'm going to go into the data manager. Each shampoo formulation that we've tested is stored in the platform alongside its measured properties and its material history. So here we have the ingredients that are used, flowing in, being mixed together. There's then a stability test performed and a pH adjustment made. Then we have a measurement of turbidity. And then the final formulation is measured for viscosity shear rate. Over here on the left, we have various different ingredients coming in. So water here and a couple of different surfactants here. Let's have a look at this surfactant. Alongside the name of the surfactant and perhaps the cost, we can also store its technical properties. And we've also put in the structural formula of that surfactant. By using this string of letters and characters, we're representing this molecular structure in a way that computers can understand. From that, we can automatically calculate 127 different things about this molecule. For example, its molecular weight or how many hydrogen bonds there are. And this kind of information is automatically fed into the AI models to support your data. If we go to the end here, looking at the final formulation, we can also store the properties that we're interested in. Once we have all of our experimental data in the platform, we're able to analyze it. We can look at it as a whole. So perhaps we want to see the spread and diversity of our data and whether or not there are any outliers. And we can also look at properties against each other. So here I've picked out two particular charts that I've made with the data of viscosity on the y-axis, and then the amount of a particular thickener is on the x-axis here, and the share of surfactants in the formulation is here. So armed with information like this, we can go back to our project and move on to AI models. In the platform, we're able to create a default AI model with 2 clicks of a button. So here it is generating the model. And what you can see here is that the training data that we just uploaded has come in at the top. It's then calculating those molecular features that I spoke about, and how much of different ingredients are in the different formulations. As we go down, it's calculating, the percentage of surfactant versus the percentage of thickener, the mean properties of all the ingredients in a formulation, etc. And then it comes down and feeds into these machine learning models. Now, this model will work, but if we're able to add our own expertise, we can make it even better. So let's go back to that branch here. And here is a model that one of my colleagues has created. It's very similar up here at the top, but then they've put in a custom formula to calculate the ratio of anionic and amphoteric surfactants here. A simple ratio that you can type in, and it's also using that in its calculations. So once you've put your expertise into the model, you're able to train it on your data and then evaluate it. And one way to evaluate it is to look at what it is saying is important in its predictions. What we have here are feature importances. These are the different properties that are being fed into the model for rheology type that it thinks are important for the prediction, starting with acid group count, thickness share, and weight. And they seem to make sense. And once you've got your model how you want it, then you have to tell it where to look. What I've done is I've labelled the different ingredients that we're trying out by the type of surfactant that they are. So we've got amino acid, amphoteric, anionic, etc. I've also labelled them either petroleum-based or plant-based. And then there's some other ingredients like a solvent, a thickener, a polyelectrolyte. And here are all the surfactants. So for each of these labelled groups, I'm able to say how many ingredients of this type are allowed in the formulation. I'm able to say what percentage of ingredients of this type should be in a formulation. And I can drill down. So in the surfactants here, I can say, only allow a certain percentage of this particular surfactant. I can also say, actually, in this formulation, let's not include this particular surfactant, or that it must include a particular surfactant. So this gives the AI model its boundaries of what it's allowed to have in the formulations that it suggests that I take to the lab. I'm also able to put in ratios of ingredients and mixing parameters and so on. So once I have my search space set up, then I need to put in targets. I can put in my targets here in terms of objectives and constraints. So remember, we're trying to find shampoo formulation that only uses plant-based surfactants, that is stable and has a rheology type of Newtonian, with a viscosity above this amount, and we'd like it not to be too expensive. So it's suggested 255 different options to me and ranked them on the likelihood of hitting my targets. I can review these 250 options here by looking at their different properties and deciding which I'm interested in, and then I can click here to go in and see the predicted properties, what the ingredients are, the amounts of the ingredients that I should use, and any other processing parameters that should be used, etc. So imagine that we've just been approached by our supplier with a new surfactant. I can drag and drop my technical data sheet into here. The platform then reviews the PDF and inputs information over here on the right. So it's pulled out the description. It's also pulled out the different values that it's seen here in their units and what type of value they are. And we're able to edit that in case it's made a mistake. And then once we're happy with it, we can submit it. So what can we do if we have a new surfactant? If we're happy with the model, then we can go into explore mode. And this is where we can try out different scenarios. I'm going to look at a shampoo formulation that I've already run experiments on, and I can see the values over here. So it's a stable Newtonian, but it's got quite a low viscosity. And I'm going to see if I can tweak that a little bit. So first of all, this surfactant here, I'm going to swap out for a plant-based surfactant. Next, we saw when we were looking at the data analysis that about 22% of surfactant was good for viscosity. So let's bump these two up to 11 each. It's automatically readjusting to keep it at 100% by using water to balance it out. The other thing that I want to do is increase the thickener, because we saw that that was important as well. So I'll increase that to 1.7 and then run a prediction of the values. So with that new formulation, we still have a stable formulation, and we're really quite confident about its stability. The rheology type is probably Newtonian, but we're less confident of that prediction. And the viscosity seems to have increased, so we're now getting a much higher viscosity. So this might be something interesting to take to the lab. So with that, what we've done is we've looked at the data that we put in, we've made an AI model, said that it has to look at certain potential ingredients. We can take out certain ingredients if they become banned or less favoured, and then rerun the candidates. We can set targets and look at the different options to take to the lab. So what I hope you've seen is that you're able to very quickly and easily ingest new ingredients into the platform, take in their data and try them out in a formulation. You can reformulate without problem ingredients simply by constraining the search space. You can save time by predicting stability, and you can reduce the number of experiments that you need to do to hit targets. We work with a broad base of customers, including personal care companies. If you're interested, you're welcome to download one of our white papers about how beauty and personal care companies extract value from AI. And finally, AI accelerates sustainable formulation. The Citrine platform is easy to adopt. The Citrine team has over a decade of experience of rolling out AI. So please do get in touch. We can help you.